Okay, let's get the. Get this going around. So just some quick announcements. The first announcement is, again, you have an exam on Friday. Jamie, our chemical hygiene officer, will be in to proctor the exam. The rules are, as they have been for the last several exams, or last two exams. Number one, Make sure your cell phones are on silent or off. Make sure you have a calculator. A cell phone is not going to count. And there are calculations on this exam, so you would be in trouble because again, you have to have a calculator. On the exam, the only thing you're going to be allowed on your desk is calculator, pen, pencil, highlighters, and you can bring food or drink. When you come in, go ahead, make sure your cell phones are off or on silent in your backpacks and put your backpacks against the wall. You will sit every other seat. There's plenty of space in this room to spread out. And so that will be the plan for Friday. Any questions? Okay, the second thing I wanted to announce is I've been asked by multiple people, and so I figured I'd go ahead, even though it will come up, you will see it in Blackboard closer to time, but Thanksgiving week, I will still have class on Monday, but I'm gonna do it via Zoom. So if you are planning to try to get out of town early, everybody should just be able to join via Zoom for that week, instead of coming into the classroom. I will not be in the classroom on that day. I will do it via Zoom. And then I just wanted to remind you, you do have a homework that it will be released as soon as class is over, and it'll be due before, due tomorrow at 11:59 p.m. Any questions for me? Okay, so on Tuesday, what we started doing is we started working with calculations where we recorded the answer to the correct number of significant digits. On Tuesday, we focused on just addition and subtraction, or just multiplication and division. With addition and subtraction, it is the number of decimal places that you pay attention to. Your answer has to have the same number of decimal places as the measurement that had the fewest. With multiplication and division, it is the total significant digits that you pay attention to. Your answer will have the same number of significant digits as the measurement with the fewest. We are going to be applying those rules, but we're going to be applying them in mixed operations. Now, with mixed operations, we are going to we're going to perform the calculations according to the order of operations, which goes by PEMDAS, which is parentheses, exponential, multiplication, division, and addition and subtraction. As we do so, you're going to see that I apply the two rules, the addition subtraction rule and the multiplication division rule. I apply those rules after each operation, but I only make note of the number of digits I'm supposed to be recording, but I don't round. You only round when you fit or at the very end of the problem. Now, the way I make note of the number of digits is you're going to see that the digits I'm dropping I will record as subscripts. That just helps me keep up with what I needed to keep and what I'm going to drop. You may have another way of doing it, but this is the way that I tend to do it to help me keep up with what I need to keep and what I need to drop. So today, what we're going to be doing is we're going to be doing these mixed operations. So let's just start out with something of this nature. Let's see. Let's go with 21.695 minus 20.795, all that divided by 23.54. I mean, excuse me, divided by 0.2354. Okay. So using PEMDAS, we have to do what's in parentheses first. So we're going to take that 21.695 and we're going to subtract out the 20.795. And if you just key it into the calculator, you're going to have an answer of 0.9. Is that the correct answer for that subtraction? Just for the subtraction piece, is that the correct answer? You're close. I do have to pay attention to something. What do I have to pay attention to? This is addition and subtraction. The decimal places. So technically that's 0, 0. Even though it's not shown on the calculator, it's still a 0, 0. And I will divide that by 0.2354. Now this is multiplication and division. In multiplication and division, what do I pay attention to? Significant digits. How many significant digits are in 0.900? There are 3 significant digits here. And there are how many in 0.2354? 4 significant digits. So our answer should be to what? 3 significant digits. So I'm going to take that 0.900 divided by 0.2354. And the answer comes out to be 3.823279524. But I'm only allowed 3 digits. Now I do have to pay attention to the digit at the end because I'm at the end of the problem here. Since that digit is less than, is 4 or less, I leave the answer alone. And so the answer I should record is 3.82. Any questions? Let's look at another example. $26.523 minus 21.96 times 31.954 plus 8.2564. Where do I start this problem? I have to start it with this piece in the multiplication. 21.96 times 31.954 gives me an answer of 701.70984. What is the rule for multiplication division? Significant digits. How many significant digits are in the 21.96? 4. And how many significant digits are in 31.954? 5. So our answer should have, at this point, should have 4. So here's what I do. I told you I can't round until the very end. But I need to know how many. So I would record this as 701.7. And then the rest of that, I am going to make as a subscript. Basically, by making it as a subscript, I'm not rounding. But mentally, I can keep up with how many digits I was supposed to keep up with. I can visually see how many digits I was supposed to keep up with. Now that I have, yes.
Subscript thing is, that's what you do. We have to do that as well.
You don't, but you can't round yet.
Right.
So you got to keep all the digits. So the main thing is you have to come up with a way to keep up with how many numbers you should have kept and what is not relevant as far as the digits to be kept. Whether that's using a highlighter, whether that's using the subscript method, this is what I do in order to make sure that I know I'm only allowed to keep 4 digits. But I couldn't round yet. Okay, now we are ready to do the rest of this math. So 26.523 minus 701.70984 plus 8.2564. And when you come up with this, it's going to give you a negative 666.93044. This is addition and subtraction. With addition and subtraction, what matters? Decimal places. So I have 3 decimal places. How many did I have in that 701.7? How many decimal places was I supposed to have? Supposed to have. See, that's where this helps. I'm only supposed to have 1. Because the former rule told me I'm only supposed to have 4 digits here, which means I'm only supposed to have 1 decimal. That's why all these are at the lower are subscripted. It's so that I know that those technically, if I were to have finished the problem, would have been dropped. So right here, I only have 1 decimal place that is valid. And on the other one, I have 4 decimals. Since 1 is the fewest, that means I only get to keep 1 decimal place here. So going through to that 1 decimal place is through the 9. Now I can round because I'm at the end of the problem. And because that's less than 4, I would just round this to negative 666.9. And that would be my answer. Yes.
So is that, so you said when we're doing these type of problems, we gotta use appendix, right? Is there any reason you didn't add before you subtracted? When you did that problem?
Usually because the multiplication and division are considered similar, are considered as a unit, and addition and subtraction are considered as a unit. So then you just go left to right. So it doesn't matter. Yes.
You said it don't matter, but if we would have did the other one, we'd get a different answer.
If you get a different answer, I'll check your answer. But normally we consider multiplication and division as a group. So we just go left to right, no matter the order of multiplication and division. We consider addition and subtraction as a group, and so we go left to right. Whereas we consider the parentheses separate, the exponential separate, the other two we consider to be grouped. Other questions? But I will double check to see if you just did it in numeric, in the PEMDAS order and got a different answer, but, yes.
I'm just making sure. So after you only put like the significant digits and the multiplication thing, you still work on like that part?
I still worked on the entire thing. I just made note of how many digits I should have kept.
Oh, wait, no, I think I said. Well, I mean, you put that down and you had like one decimal in the decimal place.
Mhm.
But you still have like the rest, so the rest don't matter in terms of like addition and subtraction.
They could have. Okay, so her question is, in this particular case, the rest of these didn't matter. That's the problem, is they could have mattered in the rounding. But they don't matter from a, how many digits am I supposed to keep perspective. But they could have mattered with respect to rounding. And so it's always best to just keep everything, but make notes.
So, in the case that they did matter, what would you actually do?
I wouldn't have done anything differently except right here. This is where it would have mattered. So that's where these digits could have had an impact, is right here.
So what would they do?
They could cause you to round up.
Oh, okay, I get what you said.
Making sense? I think more problems are in order. Okay, let's do this one. 10.2 times 2.9171 minus 18.1735 plus 11.28. I want to give you a minute to let you work on it, and then I'll give you the answer. Okay, so your answer should come out to be 22.9. The reason for it is, first of all, we did the multiplication and division. According to the rules of multiplication and division, your answer should have the same number of significant digits as the measurement with the fewest. The 10.2 had 3 significant digits, whereas the 2.9171 had 5 significant digits. So our answer could only have 3 significant digits. But I did keep everything. I just made note that I was only allowed 3 significant digits. From there, we subtracted out 18.1735 and added 11.28. Because this is addition and subtraction, the rule states that it should have the same number of decimal places. The 29.7 only had 1 decimal place. The 18.12354 decimals, 11.282 decimals. So since the one with the fewest had only 1 decimal, our answer could only have 1 decimal. When you key all this into the calculator, you get 22.86092. The 22.8 is going to be the 1 decimal, but we do have to pay attention to what comes afterwards, which is a 6. And since that is greater than 5, we round it up, so that's why the answer is 22.9. Now, I can't answer whether I feel like that in this particular case, I have a feeling that this may have made a difference. But I don't know without doing the math without it. Yes.
So, for the first part of the segment, 29.7 minus 18.1735, that was, you just subtract that, like, how did you do that for?
I just keyed it up because it's all addition and subtraction.
So you did.
Once I got to this, I just keyed everything into the calculator.
But still, I don't have mine. Instead of the 29%, I went ahead and rounded it up, and I still got the right answer.
You got lucky.
So you're not supposed to?
You should not round until the very end.
So I didn't round mine, and I got 29.7, but I got 22.8 in my answer.
But if you don't keep that 5442, you may not have all the digits. So in other words, I kept 29, when I put it in the calculator, it was still listed as 29.75442.
I only put 29.7.
See, that's where you can get into trouble if you round or if you don't round. And so that's why you gotta keep all the digits just in case.
Okay, so when we, so we just enter in the calculator, we should put the whole number with the subscript as well.
Correct.
Okay.
You shouldn't round until the end. That's why I make note. That is the entire reason why I subscripted it. Is because I did not round anything, but I needed a way to know that these were not necessarily from the rule were not to be kept. Does that make sense? But that's exactly what you can get into trouble with if you round or don't round. You might wind up off by just a hair. And in the world of chemistry, that hair can mean a lot. I mean, think about it. Somebody that has to take lithium drugs, that hair can mean the difference between the drug being effective and death. So that's why we don't round until the very end, because we've got to make sure that we're not accidentally overdosing somebody. Because a hair can make a huge difference in the world of chemistry. Questions? Let's look at another problem. And no, I never know how these are going to come out when I'm making them up.
So you said. Like if I have like an addition side on this side of the equation and like the division side, but I still use pin dots.
Mhm.
like, do
You just do the addition last. Think the answer comes out to be 28.4, but we're about to double check. Because even I can't keep up with it mentally, folks. I can't keep up with it mentally at all. So we're gonna find out. Okay, so I need to do parentheses first, so 21.23 times 18.9654. That comes out to be, so this is multiplication and division. In multiplication and division, significant digits matter. There are 4 significant digits and there are 6 significant digits. So my answer should only have 4 significant digits. So that's 402.6. And then to make sure I know that I can't round, but I'm only allowed 4 significant digits, I'm holding on to them. For the other part that's in parentheses, it's 15.2 times 2.346. This is going to be, again, significant digits because it is multiplication and division. You have 3 significant digits and you have 4 significant digits. So the answer can only have 3 significant digits. So that means 35.6592. And now to do the division piece. This one is 4 significant digits divided by 3 significant digits. So the answer should only have 3 significant digits. So that comes out to be 11.29120794. And it is that number that I add to 17.1554. Now we're doing addition and subtraction, so it's decimal places that matter. I have 4 decimal places and I have 1 decimal place. So my answer can only have 1 decimal place. So that comes out to be 28.44660794. So I would record this as 28.4 for an answer. Questions? Any questions? Okay, so just as a reminder of what's going to be on the test for those that weren't in here on time on Wednesday. There are 5 questions where you have to determine the number of significant digits in a value. I will warn you, one of those is an exact quantity. There are 4 values where you have to convert from regular notation to scientific notation. There are 4 values where you have to convert from scientific notation back to regular notation. There are 3 calculations where you have to record your answer to the correct number of significant digits. So what we did on Monday and there's only one of the type we did today. Are 3 questions where I ask you to round to a certain number of significant digits. Round a value to I ask you to round values to 3 significant digits. Yes. So it's what we've been doing here, where you're rounding to 3 significant digits. Basically, you look at the digit after and decide whether you're going to round up or leave it alone. The only thing that I will say is in that there is one of the questions where one of the things that you need to make sure you do, though. Let's rephrase that. One of the things you need to make sure you're doing when you're rounding to 3 sig figs is make sure that the value that you give me after rounding is equivalent to the value that I gave you. In other words, 310 is not the same thing as 31,000. Make sure that they make sense, is what I'm trying to say. The last page of the exam, you have 10 formulas that you have to give the name for. It's all mixed up. And you have 10 names that you have to give the formula for, all mixed up. Because on the last exam, all you had was names of polyatomic ions, names of ionic compounds, I should say names and formulas, and names and formulas for the diatomic elements, and names and formulas for hydrogen with group 16, 15, 16, and 17. But after that exam, we also went over alkanes, binary covalent molecules, and acids. So that got added into the mix. That's 20. They're roughly going to be 3 to 4 points apiece. No. The formulas and the names I'm expecting, so hold on, I'll tell you what everything's gonna be. I expect to make the formulas and the names 60 points to the test. And all of the significant digits will come up to be 90, so that's 5, 10, 15, or 5, 13, 14, 15, 16, 17, 18, 19. So those are going to be between 4 and 5 points apiece. The math will be 5 points minimum. It's probably going to be closer to 7 points, cutting down the rest of it. So all the math will be about 90 points of the test, and the naming will be 60 points of the test. Names and formulas. Any questions? If not, good luck. And I will be back